Okay, welcome back. In our today's class, we'll see how to find the limit of the cube root of x minus 1 over x minus 1. So, in this case, actually, whenever we see this limit as x goes to 1 of this cube root of x minus 1 over x minus 1, it means like 1 minus 1 over 1 minus 1, which is 0 over 0. Therefore, we are going to say the limit doesn't exist. The limit doesn't exist. But this is not the right case. This is not the right case. There is what we call a proverb in Afan Oromo, Malan Bishan Waddan. Malan Bishan Waddan. Therefore, we do it like that, like that. So to do this, to find the limit of this particular question, this is wrong, this is wrong, this way is wrong. So consider, or simply we know that x cube minus 1 cube is x minus 1, x square plus 1 times x is x, plus 1 square is 1. This is from the earlier mathematics. From the earlier mathematics, we know this. So, let's do the following. Consider x minus 1. Consider x minus 1. This is what? X to the power of 3 over 3 minus 1 to the power of 3 over 3. So, what happens is like this. This is 1 over 3, the whole 3, minus 1 to the power, or 1 over 3, again like this. This is equal to the cube root of x to the power of 3, and the cube root of 1 is 1 to the power of 3. So this is equal to, look, the cube root of x to the power of 3 minus 1 to the power of 3. Let's imitate this one. Let's imitate this one. X cube minus 1 cube is x minus 1. X minus 1. Therefore, my x in this case is the cube root of x. If this is x, I'm forgetting 3 and writing x. Forgetting this 3, writing 1. In this case, I'm forgetting this 3, writing the cube root of x. Forgetting this 3, again writing 1. So, this is like this. X minus 1. The cube root of x minus 1. The cube root of 1 is 1. Then x squared. My x is the cube root of x. The cube root of x squared plus 1 times x, or simply x, for our value is 1. Therefore, simply I write x. My x is simply the cube root of x plus, this is 1 square, it doesn't matter. 1 square is 1. So this is equal to the cube root of x minus 1, the cube root of x minus 1, this is x to the power of 2 over 3 plus x to the power of 1 over 3 plus 1. Hence, the above question, the limit as x goes to 1, cube root of x minus 1 over x minus 1 is equal to the limit as x goes to 1, the cube root of 1, the cube root of x is simply x to the power of 1 over 3 minus 1 over x minus 1. X minus 1 is simply the cube root of x minus 1. The cube root of x minus 1 is, in another word, x to the power of 1 over 3 minus 1, x to the power of 2 over 3 plus x to the power of 1 over 3 plus 1. Therefore, I do have x to the power of 1 over 3 minus 1, x to the power of 1 over 3 minus 1, both on the numerator and the denominator. Cancelling these two, this by this, we get 1 over the limb as x approaches or goes to 1 of 1 over x to the power of 2 over 3 plus x to the power of 1 over 3 plus 1 plus 1 plus 1. This is plus 1 plus 1. Hence, now we are free to insert the value of x is equals to 1 in this one. This is 1 over, as x goes to 1, 1 to the power of 2 over 3 is 1. 1 to the power of 1 over 3 is 1. This is 1. Hence, this is 1 over 3. This is 1 over 3. Therefore, the limit as x approaches to 1 of the cube root of x minus 1 over x minus 1 is 1 over 3. This is case 1. In case 2, let's let, or simply we can make it like this, or let the cube root of x be 1. This implies x equal to y cube. X equal to y cube. Therefore, and also as x goes to 1, again y also goes to 1. Hence, the limit as x goes to 1 of the cube root of x minus 1 over x minus 1 equal to the limit as y goes to 1, the cube root of x is y minus 1 over x is y cube minus 1. This is equal to the limit as y goes to 1, and this is y minus 1, y cube minus 1 cube, okay? This is simply what? From this one, from x cube minus 1 cube, y cube minus 1 is y minus 1, y square plus 1 times y is y, and 1 square is 1. Simply, this is the limit as y goes to 1, y minus 1 by minus 1 cancels. We have 1 over y square plus y plus 1. Simply the limit as y goes to 1, we can freely insert this there. This is 1 plus 1 plus 1, which is equal to 1 over 3. Both ways we get the same limit. Therefore, always whenever you meet limits of this sort, what we need to do is we need not be frustrated, okay? Whenever we come up with the value of 0 over 0, indeterminate form of 0 over 0, that should not frustrate us, okay? So we need to consider for different ways to get this limit, okay? Particularly if it is 0 over 0, we will not rush to the result that the limit doesn't exist. But what we need to do is try to look for different ways so that we can simplify this expression. So with this, we come to the end of our today's class. Don't forget to subscribe my channel, view my videos, leave the comment beneath the video. Thank you for watching.